Desalination efficiency, balancing energy and output. Desalination efficiency, balancing energy and output. As the global demand for fresh water continues to rise and traditional freshwater sources become increasingly scarce, desalination has emerged as a vital technology to address this challenge. Desalination, the process of converting seawater into freshwater, holds tremendous potential to provide a reliable source of water for consumption, agriculture, and industrial use. However, the efficiency of desalination methods is a critical factor that needs careful consideration. Achieving a balance between energy consumption and output is essential to make desalination a sustainable solution for addressing water scarcity. The growing need for desalination. Water scarcity has become a pressing issue around the world due to factors such as population growth, climate change, and mismanagement of water resources. Many regions that are already grappling with water shortages are turning to desalination as a way to secure a stable water supply. Coastal areas, in particular, have a distinct advantage for implementing desalination technologies, as they have easy access to seawater, which can be treated to produce freshwater. Desalination methods. There are several desalination methods in use today, each with its own set of advantages and challenges. The two primary categories of desalination methods are thermal-based methods and membrane-based methods. 1. Thermal-based methods. Thermal-based methods include multi-stage flash, MSF, multi-effect distillation, MED, and vapor compression distillation, VCD. These methods rely on heating seawater to produce vapor, which is then condensed to produce freshwater. While these methods have been used for decades and are known for their reliability, they tend to consume a significant amount of energy due to the need to heat large volumes of water. This energy demand can strain local power grids and contribute to higher operational costs. 2. Membrane-based methods. Membrane-based methods include reverse osmosis, RO, and electrodialysis, ED. These methods involve passing seawater through a semi-permeable membrane that allows water molecules to pass through while blocking salt and other impurities. Reverse osmosis, in particular, has become one of the most widely used desalination methods due to its efficiency and relatively lower energy consumption compared to thermal-based methods. The energy output challenge. Efficiency in desalination is a multifaceted challenge, with energy consumption and freshwater output being the key parameters to consider. Achieving a balance between these factors is crucial to ensuring the sustainability and economic viability of desalination projects. Energy consumption. Energy consumption is one of the most significant challenges in desalination. As mentioned earlier, thermal-based methods, while reliable, tend to have high energy requirements due to the need for heating. The energy source used for desalination also plays a role in determining the overall sustainability of the process. Many desalination plants rely on fossil fuels for energy, which can contribute to greenhouse gas emissions and exacerbate environmental concerns. Transitioning to renewable energy sources, such as solar or wind power, can significantly reduce the carbon footprint of desalination operations. Freshwater output. While energy consumption is a critical factor, the amount of freshwater produced per unit of energy expended is equally important. The freshwater output of a desalination plant is usually measured in terms of the desalination ratio, which is the ratio of freshwater produced to seawater intake. Higher desalination ratios indicate greater efficiency in converting seawater into freshwater. Balancing energy consumption and freshwater output is essential to optimize the efficiency of desalination. A plant that consumes a significant amount of energy but produces only a small amount of freshwater might not be economically viable or environmentally sustainable in the long run. Innovations driving efficiency. Advancements in technology and innovative approaches are helping to address the energy output challenge in desalination. Researchers and engineers are continuously working to develop new methods and improve existing ones to make desalination more energy efficient and environmentally friendly. 1. Improved membrane materials. One area of innovation is the development of improved membrane materials for reverse osmosis. High-performance membranes with enhanced permeability and selectivity can allow water to pass through more easily while blocking a higher percentage of salts and impurities. This results in reduced energy requirements for maintaining the necessary pressure, leading to higher freshwater output per unit of energy. 2. Forward osmosis. Forward osmosis is an emerging desalination process that shows promise in improving efficiency. This method uses a draw solution with a lower osmotic pressure than seawater. By creating a gradient between the draw solution and the seawater, water is drawn through a membrane, leaving behind salts and impurities. Forward osmosis has the potential to be less energy-intensive than traditional reverse osmosis, making it an attractive option for future desalination projects. 3. Hybrid systems. Hybrid desalination systems combine multiple desalination technologies to take advantage of their respective strengths. For example, a hybrid system might integrate solar thermal technology with a membrane-based process. During sunny periods, solar energy can be used to heat the seawater, reducing the energy demand of the thermal process. During less sunny periods, the membrane-based process can still be employed, ensuring a consistent freshwater supply. 4. Energy recovery devices. Energy recovery devices are mechanisms that capture and repurpose the energy released during the desalination process. For instance, the pressure difference created in reverse osmosis can be harnessed to help power other parts of the process, reducing the overall energy requirements. These devices can significantly improve the efficiency of desalination plants by utilizing energy that would otherwise be wasted. The way forward, striking the balance. As the demand for fresh water continues to rise and water scarcity becomes more acute, desalination will play an increasingly vital role in meeting the world's water needs.